All right, thank you so much. Thank you for welcoming me. And so I just quote part of the introduction. So I do work for Microsoft now, and when you work for Microsoft, they make you give up all your awards. And so I'm not an MVP anymore. I'm not a regional director anymore. I'm nothing. I'm just a Microsoft guy. But I did have a great time during all those years, and the community is fantastic. And so today I'm going to talk to you about stuff that I do in my day job, which is Azure. And we're also going to talk about Xamarin. And so just to be clear, Xamarin is a cross-platform framework. It allows you to develop applications in C# and .NET using all kinds of really cool APIs and features. It's a native application, so it runs as close to the metal as possible with great perf. And on the other hand, of course, all the services I'm going to show you can also be used from other platforms. Okay, so the Xamarin demos that I'm going to show you are examples, but you can be free to also use the services for other things. Now, of course, my personal preference is C#, .NET, etc. So I'm going to show you the examples like that. But we also support all kinds of languages in Azure, for example, JavaScript, F#, TypeScript, even Bash, and other things. All right, so I'm a cloud developer advocate. Our task, our mission, if you want, is to go around the world, talk about Azure to people. And yesterday we had a really cool workshop. I enjoyed it tremendously. It was a whole day. I was exhausted at the end, but nothing that a little bit of octopus and some Moscato cannot feel. So in the end, everything was good. And so we already showed a few of those things, but let's go again into those topics. And one really cool feature when you build mobile applications, when you build cross-platform applications in general, or just any kind of application, is serverless. So we had Joe before show you one of the frameworks existing to do that. At Microsoft, we also have serverless, and it's called Azure Functions. So what is serverless really? So there is this kind of funny joke. So there is a server, obviously, and so one of the original developers of serverless at Amazon wrote this blog post. I found it really funny. He says, well, serverless is just a name. We could have called it Jeff. And very funnily, they actually have a Jeff conference, right? So it's a serverless conference, which I think is really funny. So when we talk about serverless, it's not really that there is no server, obviously, but it's just that really you don't have so many infrastructures headaches. You don't have to worry about the server, okay? As a developer, you just basically publish your app and it runs, okay? And so that can be very useful. Of course, it forces you to think a little bit about the architecture, but one thing really cool with serverless is that it's going to scale on demand. So let's take an example. If you're a small startup and then you want to publish some APIs or publish some functions running, maybe in the beginning you just have a few customers and you want to pay as low as possible, so you can just go with function. And if suddenly you do a promotion and you have maybe thousands and thousands of customers, no problem, because we are just going to scale. We are just going to increase the number of instances that you get. And this is all automatic. You don't have to configure that. You don't have to worry about that, okay? Now, another thing cool about serverless, since it's a microservice architecture, those functions are going to run typically for very short amount of time. And we bill you only for the amount of time that they run. And so it's very cheap to run. We have an anecdote at Microsoft where a very large customer came to our accounting system and said, I'm sure your accounting system is broken because last month we ran billions of events per day, and we got the bill for 1 month, you billed us $75 US. And so everybody panicked a little bit, went to check it out, and actually it was correct because they had really architected it very nicely. Their functions were running such a low amount of time that basically it cost them a fraction of a penny every time the function was running, and in the end, it cost them really very, very low amount of money. So when you build a serverless architecture, again, it's a microservice architecture, right? It's probably the keyword, the buzzword that we hear the most in conferences these days. But it is really what it is, small units of computation, okay? Amazon calls them lambdas, we call them functions. There are all kinds of words. I think OpenWhisk calls them action, if I heard correctly, was what Joe was saying before. And each function is going to be stateless. So it gets the state from somewhere, obviously, when it wakes up. Okay, for an HTTP request, it's going to be part of the HTTP request of the URL or maybe of a form which is submitted. If it's another type of function, maybe you get state, for example, from a blob. We have those things called binary large objects. Basically, it can be an image, a video, whatever. And then you can analyze it, you can do some things, etc. And those functions are pretty independent from each other. They are going to wake up, do some work, pass the state, the output to something else, and then go back to sleep. Okay? Now, of course, they can still communicate. We have different types of messaging in Azure, something called Event Grid. We have connectors. We have all kinds of services. You can connect your functions to Slack, to GitHub, to pretty much any service that you can get. And we also have those triggers. And so when you create the function, I'll show you a demo, you're going to choose what is going to execute the function. Is it an HTTP request? We call that HTTP trigger. Is it a timer, like a schedule? Okay, timer trigger. I'll show you more triggers in the demo a little bit later. Now, one thing which is really convenient, you know that Microsoft is well known for good developer tools, and you can develop those functions locally in Visual Studio. You can debug them there. You can test them absolutely locally before you publish them, which is, of course, super comfortable. And when I say Visual Studio, I don't mean only on Windows. Of course, you can do that on Windows, but we also have Visual Studio on Mac. We also have Visual Studio Code with a function extension, and that runs on Linux, on Windows, on Mac. Very simple code editor, which is super comfortable to use. Now, when you do mobile applications, very often what you want is an API. And those APIs are going to be HTTP triggered, so it's a collection of endpoints, okay? You're going to have typically one function per endpoint, because again, you think in microservices. So if you do a calculator application, you do one function for the addition, one for the subtraction, one for the division, etc., okay? And of course, it leads to an architecture where each function has a separate URL. It's a little bit messy, okay? But you can hide all that behind a proxy. We have templates that you can select where you say, okay, if I have calculator / add / and then the numbers, then it's going to redirect to the correct function, but the complexity is hidden from the consumer of the function, which is very nice. And also, you can secure those functions very easily, okay? It's basically a web service like any other. You can add HTTPS if you want. You can also add some authentication providers, like we did in the workshop yesterday with Facebook. We also support Twitter, Google. We support, of course, Azure, AD, and all the Microsoft accounts. And of course, you can build your own custom providers if you want. So I'm going to show you a couple of demos around that, and the first thing we are going to do is go to the web portal, to the Azure Portal, which is where basically you manage all your Azure properties. And I'm going to create a new resource. And so here down there, I have serverless function application. We have quick starts and tutorials for all of those. And then you can basically fill what you need. So here you have the name for the application. I'm going to try to zoom in a little bit. The name for the application, which of course has to be unique because it's a URL at the end. The subscription, which is where you're going to be billed. Resource group is just a grouping of all the resources you have in your app. It can be the function itself. It can be a database. It can be maybe a blob storage, etc. And as you can see, we can run those functions on Windows, on Linux, using .NET Standard and .NET Core, which is a cross-platform implementation of .NET. And you can also deploy them directly to Docker, and then after that, use the container in virtual machines if you want, etc. Now, the hosting plan means this is how you're going to be billed. So typically, when you get started, you start with a consumption plan, which means that you only get billed when the function runs, okay? Of course, after a while, if you get very successful, it can be nice to have a budget. And so another way is to select here an app service plan. An app service plan is basically going to tell you, okay, I'm choosing a web server with so much RAM, so much core, so much bandwidth, etc. And then that's going to cost me so much per month. Nice thing with App Service Plan is that if you already have a web server running a website in Azure, you can actually reuse the same app service. So you don't need to have multiple app services, but you can just basically fill your app service until the capacity is reached, in which case you need maybe to upgrade to a higher one. But again, just to test things and to get started, consumption plan is a good choice. Now, regions, typically you want to choose a region which is closest to your users. Okay, in our case, it would be Western Europe, most probably, so somewhere down there. We have quite a lot of regions. And finally, we have application insight, which is analytics, so you can have a whole analytics suite added to your functions, where you know, for example, who is using my functions, where are they coming from, what language are they speaking, when are the peak times, etc., etc. Okay, in our case, I did create a function application already, so I'm going to switch to this app, and then we are going to create one simple function. Here we go. So I'm going to click here on the plus, and now we are going to see a choice of triggers. And so those triggers are going to tell me how the function is going to be executed. For example, I have HTTP trigger if I want to build an API. And by the way, you see the languages we support, C#, F#, JavaScript, okay? But a really cool thing is that we also have a whole lot of experimental languages. So if I enable that, suddenly I also have Batch, I also have TypeScript, Python, etc., etc. So you can do some really cool things with that. We also support Java, by the way. So really, we are pretty agnostic. So HTTP trigger is one choice. Timer trigger, like I said, you can say, OK, I'm going to run the function, for example, every Friday night at 11 p.m. to run some reports or things like that. If I go further down, we have things like blob trigger, where basically we say, OK, I'm going to run a function every time that somebody uploads an image, a video, a PDF file, or any type of binary object to storage. We have Iot Hubs. So if you have, for example, an intelligent house, you can collect all the IoT events in an IoT hub, and then you can run some analytics on that or any type of things. We have webhooks, so you can run some code when somebody commits to GitHub, for example. And if we go further down there, we have HTTP trigger with parameters. So that's what I'm going to take. Let's do C#. And then I'm going to give a name. And so here I'm going to say hello. All right? I'm going to set the authorization level to anonymous, which means that really anybody can go and execute this function. And now I'm creating, and you will see that you get code directly in the web browser. Now, this is great to test things out. Later, I'll show you how to do that in Visual Studio, because, be honest, as a developer, I'm not really super comfortable in the web browser to type code. But if you want to try things out, it's pretty cool. So now, how do we get parameters? Well, as you will see if you check the signature of the function, I'm going to zoom in a sec. All right, as you can see, there is a name here. And this name is going to be passed to me because it's a GET request from the URL. So if I go, let's save first, OK? If I go to the Integrate tab down there, as soon as it's done saving. All right, everybody stop tweeting right now. OK, I'm just going to go to Integrate. All right, here we go. It's saved, actually, in the meantime. So if I go to Integrate, this is how we see where the inputs and outputs are going. And one important thing, because it's an HTTP request, is that we have here a root. And this root is going to tell me it's going to be part of the URL if you want. So I'm going to change here this name, which doesn't make any sense to me. I'm simply going to say hello, for example. And then I will have the name parameter. And then those squigglies here, those curly brackets, means it's the parameter that the Azure runtime is going to extract from the URL for me and give it to my method. And here we have the get HTTP method selected. I don't go with post, delete, etc., but I could if I wanted. So now I'm going to save this. And then if I go back to the code, this is where you see the code that is going to be executed. And now I can, to test things out, I can go and say, OK, let's say hello from Greece. And then, of course, from the moment where I save, my function is already ready to use because it has been deployed. It is already running serverlessly. So I'm going to take the URL of the function. Let's go into the web browser, type that. We see the root that we just defined, hello/name, and then the name in question. So let's type, for example, Laurent. And then if I execute, after a very short wait, we will see hello from Greece, Laurent. This XML has been actually added by Edge, but what is passed to me is just a simple string. And of course, because it's a string, right, we do HTTP, the text protocol. Because it's a string, I could also pass JSON or XML if I wanted to, no problem. So like I mentioned, this is cool, but who wants to do some code in web browsers? I know that I don't really want to do that. So of course, I'm going to switch my favorite development environment, which is Visual Studio. And now if I go and create a new project, it will give me a choice of templates, including Cloud Azure Function. And so I can go and say, OK, let's name this, for example, LB calculator. I say LB because those are my initials. And if I create this, it's going to create a new project. Now I need to select the HTTP trigger that I had before. And by the way, here, as you can see, I can also select Azure Functions v2, which is using .NET Standard, which means that I can deploy this to Linux if I want. That's going to run seamlessly on Linux as well as on Windows. I'm not going to select a storage account because I don't need that in that particular case. Let's just create this. So it's going to give me some code. All right? And so now I can start doing my function. So I'm going to say the first thing, I'm going to rename this to add. It's not super easy to code on thing like that, so I don't recommend it, but we're going to do it anyway. So here I have the function, and now here the configuration in Visual Studio is done through those attributes. So what I did before in the Integrate tab, here I do it with those attributes. So I'm going to set the authorization level to function, that's fine. I'm going to change here the method because I want get, but I don't want post. So I'm just going to remove the post completely. So let's do that. And now I'm going to select the root, which is again part of the URL, okay? And so just like before, now I'm going to say, okay, my function is called add, and then I want two numbers, so I'm going to say I want the first number, and then I'm going to put the squiggly, which again, the Azure Function runtime is going to extract from the URL. Then I'm going to say I want the second number, again, another squiggly. And then, how do I access those two numbers? Well, very simply, I'm just going to add them to the signature of my function. So they are going to be given to me as parameters. And the really cool thing is that I can say I want them to be integers. Even though what is given to the URL is a text, the Azure runtime is going to convert that to integers automatically. And so finally, we can go and type a little bit of code here. So before, we just pass a simple string to the result, which was a little bit annoying, like a little bit simple. So here instead, what I'm going to do, I'm going to pass an object. I'm going to say, OK, I want to create this class addition result. So first of all, I'm going to define here the date time, OK? Then I'm going to create this new class to say, OK, that's the result that I'm going to pass to my client, OK? And if we go and check this addition result, we see that we have two properties. We have the result, which is an integer, and then we have the time on the server, because why not? Okay, just to say, okay, we pass something to the client. And so finally, I'm going to return here an OK object result, which means I'm going to pass HTTP 200. And I'm going to pass the result, which means that under the cover, it's going to automatically be serialized to JSON and given to the client, which is quite convenient. Of course, I could do all that in JavaScript, in TypeScript, in Bash if I wanted, but here I choose C#. Cool. So now, how do I debug? Well, I am totally local here. I'm going to start this in the console. The Azure Functions runtime is starting up, and that's exactly the same runtime that we have on Azure. It's not a simulation. It is the exact same runtime. Admire the ASCII art. That's pretty cool. And then we have, at the bottom here, a URL. I'm going to copy that. OK? I'm going to go into any web browser, paste that here. And now let's take a look at this URL. So what do we have? We have, first of all, localhost. OK? It's running locally. Then we, I do that every time. Then we have the numbers that we want to give. So let's zoom out. I'm going to add two numbers. I'm going to add here 12, and let's add 30, for example. And now if I press OK, it's going to jump into Visual Studio, and I have a great debugging experience totally locally, which means that I can go and press F10 to step. I can inspect my result object. I can check how much is 12 plus 30. It's 42, of course, because it's the answer to life, the universe, and everything. And then I can run. And I'm going to get here some JSON in my web browser. So that's pretty cool. At this point, I would deploy to Azure. And so in order to deploy to Azure, what you want to do is have some script, some continuous integration, and all that. But if you're just testing things, I'm sure that Jim is taking a picture right now, because I'm going to right-click Publish, which you shouldn't do in production, OK? You want really some reproducible steps, some scripts, etc. But here you can go and say, either create a new Azure App Service, which is what I did before in the portal, or I can select an existing one, in which case it will connect to my subscription and propose to me a list of existing applications. Cool. In that case, I did that already, as you can imagine. So if I go and take this LB calculator down there, we have a function called add. And here you won't see code because I published that from Visual Studio. Okay, so the code is edited in Visual Studio, but I do have a URL for it. So I'm going to copy that. And now, how do we build a client? So like I told you, my favorite clients are Xamarin clients because you can use C# also, and you're going to deploy that to iOS, Windows, and Android. So here we have an application. It's using Xamarin Forms. As you can see, I have an Android project, an iOS project, a UWP, Windows 10 application. And let's take a quick run through the code. I'm not going to code in front of you to be a little bit more efficient, but basically this is the URL that I just copied. This is the URL of the service, okay, with a root. Then I have an HTTP client, which is the way that we do HTTP requests in .NET. And finally here, this is all just boilerplate to kind of verify that the numbers are actually numbers, so I'm just validating that. And here I'm replacing the number, the first number and the second number in the URL. I'm calling the JSON asynchronously, and then I'm deserializing. And to deserialize, I'm using the exact same addition result that we used just before, if you remember, the result and the time on server. So I'm sharing that through a class library just to be easy. And so once you have that, you can check that it's running. So for example, I have this application here on Windows, and it's exactly the same UI. Oh yeah, I didn't show you the UI. That can be interesting. So we have the UI here expressed in XAML. So we have one entry, another entry, we have the button, and then we have the label for the result. So translated to Windows, this is what we have. We can try again to see if it works. After a short while, we see that. And then I can show you also an Android. So what I'm going to do is connect to my Android phone, which is right here. All right. OK, let's view this Android phone. So this is my physical Android phone running here. OK. So I can go to this screen here. This is exactly the same UI, running natively with native user controls on Android. And I can enter, again, the thing, press on add, and after a short wait, we should see 42 as well, which is pretty cool. So it works. I don't show you iOS, but you can believe me, it works as well. All of this is public on GitHub, and you'll get the links to those repos at the end. So serverless, really cool to build. Very fast, some APIs. You can also have, like I said, other time of triggers. You can have a whole architecture running in the cloud at very low cost. All right, so let's talk about something else. First of all, self-promotion. If you liked this demo, there is a demo with a step-by-step explanation at this URL, so you can go and check it out. It's one of the official Azure samples. Now let's talk about data, because data is really super important. In fact, I would go as far as to say that without data, there wouldn't be a cloud, there wouldn't be Azure. And so, of course, in Azure, we have a lot of ways to store data. So SQL Server is still very much there, okay? So SQL Server, for example, if you have a scenario where you have an SQL Server on-premise and you want to put your application in the cloud at very, very minimal cost, well, you just spin an instance of SQL Server in Azure, copy your data, pretty much change the connection string in your client, and then you're good to go, okay? That's what we call lift and shift. You lift, you shift, okay? Now, another way to do data in Azure is called Azure Tables. It's very cheap, quite fast. It's not very powerful, but it's NoSQL, it's schemaless, so it's very modern. I would say you can just basically feed your objects to the Azure Table infrastructure, and then it's going to save that. That's quite convenient. But one thing which is a little bit more powerful, it's like an upgrade if you want, is Cosmos DB. We'll talk more about that in a sec. Now, of course, if you have huge amounts of data, we have our data lake offering, where you can do some analytics, some reporting, etc. So let's talk about Cosmos DB, because it's the newest offering we have. Cosmos DB is a globally distributed data service. What does it mean? It means that you're going to define a location to write the data, but then after that, we are going to replicate the data automatically to some read locations that you define. So for example, if you have some users in Australia, well, we can only go as fast as the speed of light. Yes, even at Microsoft, we can go faster than the speed of light. We tried. It didn't work. So the next best thing is to move the data at the location closer to the users. Okay? And so that works well. But of course, it takes a lot of work to write the code to do that. Well, not anymore, because we do that for you. So we are going to guarantee that your data is replicated in a good manner. Okay? Now, the other thing which is cool with Cosmos DB is that if you have an existing database application using one of those APIs, we offer those APIs as well. So for example, if you have a MongoDB app, or if you have table storage, the Azure table scenarios that I said before, okay, you start with Azure tables because it's easy and doesn't cost much, but then suddenly you see, okay, now I have really millions of rows, it's too much, I'm going to move to Cosmos DB. You can reuse the same APIs, and the changes to your code are really minimal. So what is a typical architecture for a Cosmos DB application using mobile? Well, typically what you're going to have is a protected write scenario. And to do that, Azure Functions are great because you can protect them. You can easily add some authentication, for example, like we did yesterday with Facebook, Twitter, or other providers. And so the write is going to go to a location, but then after that, you're going to say, I want this data to be synchronized to other read locations, and then your clients are going to be able to read from the location which is closest to them. Now, that's really convenient because it allows us to give you what we call SLAs, service level agreements. It means that we guarantee that the read time and the write times are going to be below a certain limit. And if we go slower than that, okay, we're going to check it out. If it's our fault, you get your money back. Okay, and that's a guarantee that we give you. So this is a cool thing in Cosmos DB. So a quick example of Cosmos DB, I have an application which is here, and this application is called GeoContacts. Now, it's an application that we developed together with the Xamarin team, and in fact, it's a pretty cool app. So I'm going to start it here on my Android device, but again, it's an application using Xamarin, so it's going to run on iOS and Windows as well. And so here we have a list of all the developer advocates, so you can see, okay, you can select one and check what is Steven doing, for example, his bio, etc. So this is a read. Everybody is able to do that, and so in that case, it's going to read from Western Europe because we have some data, one of the set of data in Western Europe, it's closest to us. But I can also write, and so if I go to this tab, since I'm logged in using my Microsoft account, and by the way, again, the code is totally public, so you can go and check it out on GitHub to see how you do the authentication and all that. In that case, I'm already authenticated. I can go here, and I can save my location and say, hey, right now I'm in Thessaloniki. And so after that, as you as a user, you cannot save your location, but you can go and check who is a nearby CDA. And after a short wait, you should see that I am nearby. And so you can send me a message on Twitter and say, hey, come and have some ouzo at my place. Just a hint. OK? I'm leaving tonight, unfortunately, but I'll come back. So you check it out from time to time. So this application is all on GitHub. You can go here, and basically a few things that make it work. We have here some keys. Okay? This is a read key, which is going to say to Cosmos DB, hey, I want to read that particular database. Please give me, direct that to the database which is closest to the location. And then we have here the update location view model. We have a few things here. The first thing is update location is going to write, let's see. Update location is going to write, actually I want the Azure Data Service, here we go. Update location, this method is going to write using a function. So just like we did before, we are using an HTTP client to post some JSON to a function. The function is checking the authorization and writing to Cosmos DB, okay? On the other hand, for the read, if you go and check get all async here, for example, here we are using this client. It's a doc client which is given to me by the Cosmos DB SDK. I'm using here the document API, which means I can do some link requests, for example, for SQL requests, etc. And this is going to give me access to all the data directly using the closest location to my place. All right, I want to quickly show you this database in the Azure Portal. So of course, you don't have access to that, but because I'm an admin, I have access to this. So this is where I can manage my database. In that case, we see that the data has been replicated. This is the right location. It's in Western US. We have one read location in Eastern US. We have some in Europe. We have some even here in Seoul because we have a few of my colleagues are doing a tour in Korea at the moment. And so if I wanted to add some data somewhere, I can replicate data globally. I can go down and say, for example, I'm going to go in Australia in September. Why not save a set of data here? From the moment where I click Save, it's going to automatically send the data there and guarantee that it is always there. Finally, the SLAs. So if I go to metrics down there, you can check all the data. For example, interesting, the latency. Okay, and like I said, we guarantee some read latency of 10 milliseconds at most, and here you can see that actually it's closest to 1 millisecond, and here we have the write, which is closest to 5. If we go higher than that, we give you your money back. Okay, the last service I want to show you is cognitive service, and it's probably the funnest of all. So cognitive service, basically artificial intelligence, machine learning is really hard. Okay? We need data scientists. We train them for years. We pay them a lot. Good career opportunity here. But it's really hard. You need to do all kinds of really crazy maths that I did in engineering school last time, probably 25 years ago, and I couldn't anymore. So instead, what you can do at Azure is use our cognitive services, where basically we did the heavy lifting for you. And then we offer those services as a convenient set of services. For example, we have language recognition. Okay? Recently at Build, at the conference in Seattle, we had an app with the conference, and you could go and say, okay, now I'm in this session, and by the way, can you please give me the text of the session in Russian or in Greek, for that matter? And they would automatically translate as the speaker was going, and this is all machine-powered. Okay? So we have these kind of things. We have speech recognition, of course. We have vision recognition, where you can recognize, for example, a face, okay? Do I look like a celebrity? Or am I allowed to enter the building at a more practical level, maybe? Or what is on this picture? These kind of things. We have search, we have knowledge database, etc. All this is packaged as REST APIs, so you can use them from any application super easily. And we, in fact, we even have some SDKs developed as NuGet package, NuGet being a package manager that we use a lot in Visual Studio. And so let me show you a demo. So this demo is going to show you again a Xamarin application, okay? And so this is my custom vision client here, which is again running on Android, on iOS, and on Windows without any change. So let's take a look at the code that we have. So the first thing that we can see is that we will need some keys. We need a prediction key and a project ID. So where do I get those from? Here we have this website called customvision.ai, okay? Now here I can create a new project, and in that case I already created a project here in the portal, and I uploaded some pictures of fruits. So I have oranges, I have apples, and then I said, okay, all those fruits here are apples. So you see down there we have a tag saying apple. And then if I click on orange, all those fruits here are oranges. So here I uploaded just a few pictures. Ideally, you would like to upload maybe about 30 pictures per tag, okay? Here I chose fruit, but basically you can recognize anything, okay? Cool, and then I went to get the keys. So here I have the prediction key, and I have the project ID, and I saved those in the settings. I don't show you the code to do that, but basically you believe me, right? So I have the prediction key, I have the project ID. Then I did a little bit of UI, and again, this UI is going to be translated. We call about rendering. We render the UI to iOS, Android, and Windows using native controls. So this is all going to run natively. So we have a grid, okay? We have a label for the result. Right now it says welcome. And then we have an image, which is the image that we are going to take with the phone just to show it. Then we have a button. And this is a go button, which is going to take the picture and start the process. And finally, here's the code. We have a prediction endpoint. So where does that come from? Well, basically, we have, where does that come from? Sorry. Basically, we have here a package manager, okay? And in this package manager, I selected here Microsoft.cognitive.customvision.prediction, which is an SDK which is basically wrapping the REST calls that we do. But if you prefer, if you do something which is not .NET, JavaScript or anything else, you can do some REST calls to the service as well. We have a whole-blown REST APIs. In fact, the SDK under the cover is going to do REST calls as well. It's just a little bit more convenient. Taking pictures is also done in a cross-platform manner. I'm using this xamarin.plugin.media because taking a picture on iOS is not the same as on Windows or on Android. So this plugin is going to abstract that for me and basically let me use it without anything else. And so I can go here. I can say, all right, I initialize the prediction endpoint. Then I'm going to initialize my cross-media, my plugin to take pictures. Then I'm going to take the picture. Here I write the code once, but it's going to do the thing in iOS, in Windows, in Android. And finally, I'm going to recognize the picture, which is really as simple as calling predict image on the endpoint. Again, if you do that with something else than .NET, you can also do that, but you have to send a REST call. And finally, I will get a list of probabilities. It will tell me, OK, if it's higher than 0.5, which is 50%, I'm going to say, OK, that's the best tag, so I'm going to show that. Otherwise, I'm going to show not sure, and then I'm going to show all the tags. So let's try. I have here my visor, so I'm going to take this client, custom vision client. And so I brought some props, fresh from the Kapani market, I believe. Yep. And I'm going to take a picture. So let's try with an apple. The lighting is not great, but hopefully it will work. So I'm going to send this to the service. It's going to take a moment for the round trip. And it's going to tell me, yes, that's an apple at 97.4%. Nicely done, right? Cool. The AI says thanks. But now let's try with an orange, OK? So, OK, orange, boom. Orange. Sometimes the orange, I get some weird. OK, this time it worked well. Pretty cool. Now, so those of you who have children, right, the first time you show this to a child, he's like, oh, no, it doesn't work, right? OK, that's a gun. Cool. Well, no, it doesn't work. You have to train him. You have to tell him, no, you have to, that's a banana, OK? So if I take a picture of the banana now, the service is going to tell me, well, yeah, well, I'm not quite sure what to do with that. Okay, might be an apple at 2%. Basically, he doesn't know, right? So let's train the service. So in order to train the service, you have multiple ways to do that. You can go, for example, and do that from an app. We have an SDK for that. But here I'm going to do this in the web portal directly. So I'm going to go and add some images. Let's browse local files. And it so happens that I have images of bananas. Now, one thing which is really funny is that those bananas, I downloaded them from the web. They are all heavily photoshopped bananas. They look great. They are all yellow. Now, a real banana doesn't look yellow. It has a lot of spots, right? So my service didn't quite know what to do with that. So I had to go and take some real pictures of bananas because bananas are diverse, right? Recognize the bananas who have spots. And the one with the black background are my own pictures. And then suddenly the service was working great. So I'm going to take all the bananas here, send them to the service, and I'm going to say this is a banana. Voila. Let's add the tag. And then I'm going to upload. Takes a couple of seconds to upload the pictures. And when it is done, which gives me a nice water break. All right, once it is done, I'm going to train my service. So I trained it already a few times with the pictures that we had before. Now I'm going to train it again, this time with bananas as well. The training typically takes like 15, 20 seconds, maybe less. And once it is trained, you get basically a new iteration, which you're going to say, OK, that's my default iteration. That's the training step, if you want, that I want to use right now. I'm going to make this default. And now the cool thing is that because everything is online, everything I did doesn't require any change from the application. But this time I can take a picture again of the banana. And hopefully, if the lighting is good enough, the service will have learned and say, well, OK, he's still not quite sure, but at least 10% it's a banana. Let's try again. I'm going to put it in the spotlight like this. It looks a little bit more yellow. And hopefully, it will be a little bit better. But basically, you get the idea. You can train your service. Now it's 25%, a little bit better. Maybe it doesn't have enough spots. Anyhow, you see how you train your services. Now, this is all, of course, online. OK? So I need to send a request every time. It's a little bit time-consuming. There is latency. The advantage of this is that I can train my service as I want and refine the service as we go. But a really cool feature of all this is that you can also export the model that you created, import it in your Xamarin application, and run it totally offline. And so that allows you to do calls a lot faster, for example, out of video. So we have some applications where you can just put a banana in front of the camera, it's filming, and basically it's analyzing as we go. So that's also pretty convenient. All right, so I'm at the end of the presentation. I have a lot of resource slides. So if you want to get started with all those services, this is Azure Functions, okay? This is Cosmos DB. This is Cognitive Services. Basically, all you need is at this gslb.ch/devit18, you will get the source code, all in GitHub, you will get the slides, and everything you need. If you want to start with Azure, we offer free accounts. You get $200 for 30 days where you can try anything you want. After those 30 days expire, you get another year on selected services for free. Okay? And we have in Azure also 25 services who are always free and will always be free. So it's a great occasion to start. If you work with students, you can go to this URL down there, and then you have the possibility to create accounts in bulk for all your students and let them try the services that we have. I hope you like this presentation, and I really hope it was useful to you. I will stick around until tonight, not to drink ouzo, but to get questions, okay? And so thank you very much for your attention, and have a great end of the conference. Thank you.
So, thank you so much, Laurent.
Thank you.
Do you have any questions from everything that was said and everything that was heard by you regarding what Laurent was saying?
How about over here?
Please raise a hand.
I'm wondering if your fruit AI will recognize hot dogs.
So we did one better. We have an application which is actually called bacon.bacon, because hot dogs are kind of but bacon, everybody loves bacon. So yeah, we do have that.
Well
it does work.
Well done.
Thank you.
Okay, anyone else, please raise your hand so that we can see you. Okay. Yeah.
Does it work?
Yep.
Do we have access to the underlying models of these services? Can we know which model is used, which algorithm?
Yes, so for certain services, no, because those are either in preview or they are, just packaged as is. For certain services like the one that you did, yes, you can download the model. So basically, once you download the model, then you can also import them in some workbooks, for example, Jupyter notebooks, etc., and refine them or check them out. Yes.
Okay.
Yeah. So certain of those cognitive services allow you to do that. Yes.
Okay. And about the training process, is it only done manually on demand by me, or is there an API?
Nope. That's an API. So here I showed that just for effect, if you want, in the web portal. But of course, in practice, we would write some scripts to do that, and then we have an API for that. So just like I did, I downloaded a package for the prediction. There is also a package for the training, and then you have all the APIs that you need. Or of course, everything is exposed as REST APIs as well, so you can do that. Yeah.
And is there an API for incremental training every time
correct.
a new classification is in? Or?
Yes, you can do that. So here I was using the free tier, which gives you, I forget now, a couple of hundred iterations for free. If you want more, then you have to start paying, obviously. But yes, you can do that incrementally using scripts, for example, or using programs as well. Yeah.
Okay. Thank you.
Cool.
So, any other questions?
I will stick around for the rest of the time in case, but maybe one more? Okay,
yeah,
let's take one more. Cool.
One more would be good.
All right, so.
Yeah, could you pass the mic, please? Yeah.
Hi. I wanted to ask if the functions, when you use JavaScript, are using Node.js or some
Node.js.
Some other context? Okay.
Yep. Yeah, we are pretty. I mean, we do use quite a lot of things, obviously, but on the server, we use Node.js pretty heavily, so it's Node.js under the covers.
So it's similar to AWS? Right?
It's similar in a way. I'm not sure that you can really port directly because the APIs might be a little bit different, but in terms of how it works, it's very similar, yeah.
Because Google Cloud Function does not use a JavaScript engine, use a custom JavaScript engine, right? So
I'm not familiar totally, so I have to believe you on that, but I know that on Azure we do use Node, yeah.
Okay, so I could take my code from AWS and have the hope
probably
to
with
port it
with
to
a few
Azure.
modifications, but in general, it's going to run. Yeah.
Okay, thank you.
Yeah. Okay. Cool. All right. I don't want to take time from the other speakers, but thank you so much. Again, find me if you want to talk. All right. I always appreciate that. Thank you.